mission of Ccas is to make synthetic chemistry more predictable. And as part of that, we bring together people with complementary skill sets and approaches from the molecular through the computational sciences. And we're engaged in trying to take the data that we have already and use that effectively to plan and execute chemical synthesis, but also thinking about the new ways that we can actually generate new data sets and new tools that will allow us to take this forwards. The totality of the problem is such that we need all of these people with different skill sets and approaches to really make a dent in this problem, first of all. So I think it's important that we bring together people from chemistry and computer science and folks in the middle so that we can actually address this problem. And the pace of ML and AI is such that it's really hard to sort of keep on top as a chemist. So we really need the expertise from our friends in computer science to really address these problems. Speaking as a chemist, it can be daunting to sort of enter that world of computer science and machine learning, and I'm sure the other way around, similarly, it can be sort of phasing at first. But I think part of sort of breaking down these barriers is actually working directly with groups, right? So we have this center, we're able to actually get on Zoom calls, we have meetings in person, we collaborate directly with the groups. And I think that's one of the great strengths for the graduate students in Ccas, that they have this just big base of knowledge that they can tap into, and hopefully if there are areas that are a bit sort of confusing, they have someone they can go ask. So Ccas indeed has aimed to educate the next generation of what we're going to call data chemists, and I think this reflects the fact that chemistry increasingly needs to use the data that we have already and think about how we can be more efficient in collecting new data sets. So I think it's hard to know every single technique from machine learning and AI, but the kind of skill sets and knowledge that we can instill in the students of Ccas are understanding the fundamentals of these approaches and tools, and of course the practical skills that are going to allow them to be flexible and hopefully learn these emerging techniques as they arise. And often that will be independently as well. So I think that we're really sort of upskilling these young chemists so that they can then go on to really learn. So for young scientists, chemists, computer scientists who are interested in sort of working at this interface of chemistry, synthesis, and computer science, that's not really something that necessarily has an obvious undergraduate major or minor combination, let's say. But I think there's a lot of tutorials and Jupyter notebooks that are out there increasingly on the web, which I think make a really sort of good introduction to the topic. And of course, Ccas has its own sort of set of videos on YouTube that hopefully sort of give a little taster to some of these topics. And then I think the next step for the younger generation of scientists would be doing a research rotation in the laboratories of Ccas. And again, that's something where we have summer research programs, the RU experience, which has already got off to a great start. So in terms of the broader impacts of Ccas, the obvious one is that chemical synthesis is absolutely integral to making the molecules that really kind of make a difference in modern life. So medicines, materials, optoelectronics, and obviously if we are more efficient at planning the way that we actually do synthetic chemistry in the lab, that can be more data-driven, more predictable, then hopefully we can start to focus more on the types of molecules that we need to make and maybe a bit less on how to make them or whether those actual syntheses are going to be successful. And I think that will obviously allow us to think also about designing the molecules that we need to address these future challenges. So what are the medicines and materials that we can think about actually predicting first, and then also thinking about how they can be made in the laboratory. So I think that's really exciting and obviously goes way outside of purely academic interest. Machine learning and artificial intelligence are certainly here to stay, and so I think the center hopefully just is part of a larger sort of movement that seeks to incorporate these genuinely useful tools into chemistry. So the aim is not to replace the existing chemists, but to provide a set of tools, a way of thinking that hopefully enriches chemistry doesn't seek to replace the field in that sort of sense.